What if I told you that the sunlight warming your face this morning began its journey hundreds of thousands of years ago, deep inside the sun's heart? Chapter 1. The Poetry of Light. Imagine standing at the edge of dawn. The horizon glows, shadows retreat, and the first beam of sunlight breaks through the silence of night. For us, this is an everyday moment to sunrise. Yet behind that golden light lies a story that begins in a place more violent and mysterious than anything on earth. The core of our sun. What you see when the sun rises is not just light, it is history. Each photon that touches your eyes has already lived a lifetime before reaching you. It began its journey deep inside a nuclear furnace, long before humans walked the earth, long before our planet even looked the way it does today. The sunrise you watch today is, in many ways, ancient light finally finding its way home. Let's step into that story. We often think of sunlight as instant. The sun shines, and in about 8 minutes, light arrives on Earth. Simple, right? But that's only the final act. The truth is far stranger, almost poetic. The light we see in the morning could be hundreds of thousands of years old. That means when you look at the sun today, you are not just seeing now, you are seeing echoes of an unimaginably distant past. The journey begins in a hidden place we will never see with our own eyes. The sun's core. Imagine it as a heart, beating endlessly, pumping energy out into the universe. But unlike a heart of flesh and blood, this one burns with unimaginable heat. It is a place where matter and energy collide with such force that atoms are torn apart and reborn. It is, quite literally, the birthplace of light. Before we go deeper, pause for a moment. Look around you. Every tree, every breath of air, every piece of life on Earth owes its existence to those first sparks in the sun's core. Without them, our world would be cold and silent. With them, Earth is alive. Now, let's return to that single photon. Picture it forming in the heart of the sun, where temperatures climb above 15 million degrees Celsius. Here, hydrogen atoms smash together and fuse into helium, releasing enormous amounts of energy. This energy does not appear as warmth or visible light right away. It appears as high-energy photons, tiny particles of light, carrying the raw power of nuclear fusion. At first, it may seem like this photon has a straight path to freedom. After all, light moves fast 300,000 kilometers per second. But the sun is not an empty space. It is a dense, chaotic ocean of particles. Every inch is packed with atoms ready to scatter, absorb, or redirect the photon. Instead of flying directly outward, the photon is trapped in a maze, bouncing around endlessly. This is where the story becomes almost dreamlike. Imagine being that photon. You're born in a blinding flash, carrying the heat of the sun's core, eager to escape. But as soon as you move, you're stopped, pushed aside, thrown back. It's like trying to leave a stadium through a packed crowd, only to be shoved in a new direction every step. Progress is slow, very slow. Scientists call this process the random walk. Each collision changes the photon's course, scattering it at a new angle. Sometimes it moves forward, sometimes sideways, sometimes even backward, deeper into the sun again. Over and over, for thousands, millions, billions of collisions, it struggles to move. And here is the astonishing part. This random walk can take hundreds of thousands of years. Yes, years. A photon created in the sun's core during the Ice Age may only now be leaving the sun's surface, destined to touch your face during a sunrise today. This hidden history changes how we see light. Sunrise is no longer just a pretty picture in the sky. It is the result of a journey that began before any of us were alive. The warmth on your skin today could have been trapped in the sun while mammoths roamed the earth. That's the poetry of light. It connects us not only to the sun, but also to time itself. It makes us realize that even the most ordinary moments carry extraordinary stories. Why does this matter? Because it reminds us that science is not only about numbers and facts. It's also about perspective. To know that every beam of sunlight is a survivor, a traveler, and a messenger from deep time that changes how we relate to the world. It's not just physics. It's philosophy. It's beauty wrapped in truth. Next time you see light filter through the trees or sparkle on water, think of the path it took. Think of the collisions, the struggles, the centuries of delay. What feels like a moment is actually a cosmic journey across time and space. In this chapter, we've only begun the story. We've painted the sunrise, introduced the photon, and hinted at the long, impossible struggle ahead. But there's much more waiting. In the next chapter, we will dive into the sun's core itself, the engine of fusion, the true birthplace of every photon, and the fiery heart that has kept Earth alive for 4.5 billion years. For now, remember this: sunlight is never just light. It is time, it is history, it is survival, and it is the most faithful companion Earth has ever known. Chapter 2: The Core. Sun's nuclear heart. When we look at the sun, we see only its surface, a glowing disk, brilliant and steady, rising each morning and setting each night. But the calm face we see is deceptive. Beneath that surface lies a world we cannot touch, cannot see, yet depend on for every second of our lives. This hidden world is the sun's core, the nuclear heart that powers everything. It is a place of extremes, a realm of pressure and heat so far beyond human experience that numbers almost lose their meaning. Yet it is here, in this unreachable heart, that the story of light truly begins. Imagine the center of the sun as a massive engine, but one unlike any machine we've ever built. Instead of pistons or turbines, its fuel is hydrogen, the simplest element in the universe. Its product is helium, a slightly heavier element, and the process that links them together is nuclear fusion, the most powerful source of energy known. At the core, the temperature soars to around 15 million degrees Celsius. The pressure is crushing, about 250 billion times greater than Earth's atmosphere at sea level. In this extreme environment, hydrogen atoms are forced so close together that their natural repulsion, the push between positive charges, is overcome. They collide, fuse, and in that instant, release energy. That energy takes the form of photons, tiny packets of light, born in a blinding flash of nuclear fire. But these are not the warm yellow rays we see at sunrise. In the core, photons begin as high-energy gamma rays, invisible to our eyes, violent and intense. To understand how chaotic this place is, picture yourself inside it. You wouldn't see open space. You wouldn't even see anything resembling matter as we know it. Instead, it would feel like being caught in an eternal storm, particles colliding, smashing, shattering, merging, every direction filled with motion. Protons, the building blocks of hydrogen, slam into each other with relentless force. Every second, in every cubic meter, trillions of collisions occur. Out of these collisions, helium forms, and in the process, a photon is released. That photon is energy. That photon is the beginning of the sunlight that, one day, may touch your skin. It's hard to imagine the scale. Every second, the sun fuses about 600 million tons of hydrogen into helium. Out of this, it converts about 4 million tons of matter directly into energy. Following Einstein's famous equation, E equals mc, that's enough power to light billions of Earths. And yet, to the sun itself, this is just routine. It has done this for 4.5 billion years, and will continue for billions more. Now, let's return to that single photon. Picture it being born in the chaos, a spark of light released during a fusion event. It exists, carrying unimaginable energy. If space around it were empty, it would race outward at the speed of light and reach the surface of the sun in just 2 seconds. But the sun's core is anything but empty. The core is dense, so dense that it's often compared to solid metal. Photons cannot move freely. Instead of flying in a straight line, each photon's path is blocked almost immediately. It travels a fraction of a millimeter before it collides with a particle, an electron, a proton, or even an atom. With each collision, it is absorbed, re-emitted, or scattered in a random direction. The result is a journey that feels less like flight and more like being trapped in a maze. Scientists call it a random walk. For the photon, there is no straight path, but only endless collisions, redirections, and delays. Imagine trying to leave a crowded stadium where every step forward pushes you sideways, backward, or into a wall of people. Progress is slow. Sometimes, after a collision, you may even find yourself further from the exit than when you started. This random walk is not just slow, it's agonizingly slow. On average, a photon can take 100,000 to 1 million years to travel from the sun's core to its surface. Think about that. The light warming you today may have been born long before human civilization existed. Some photons that started their journey during the time of early mammals may only now be arriving at the edge of the sun. And yet, despite the struggle, photons never give up. With every collision, every detour, they move closer to freedom. They endure unimaginable density and pressure, scattering endlessly, until one day, they find themselves near the sun's outer layers, where the environment finally begins to change. The scale of this process is staggering. Every second, the sun emits 3.8 x 10 watts of power, a number so large it's almost impossible to grasp. To put it into perspective, the sun produces more energy in a single second than humanity has used in all of recorded history. And at the center of it all are photons, countless photons, each born in the same chaos, each struggling through the same endless maze. This is why the sun's core is not just fascinating, it's vital. Without it, Earth would be frozen and lifeless. Without it, there would be no oceans, no forests, no us. The core is the true heart of the solar system, and its steady pulse of fusion is what sustains life on our planet. Chapter 3. The long sleep of photons. Close your eyes for a moment and imagine this, a tiny particle of light, born in the blazing furnace of the sun's core. It is pure energy, the child of nuclear fusion, carrying with it the story of creation. You might think it rushes outward, like a beam from a flashlight, instantly leaping across the solar interior. But the truth is far stranger, and far slower. That photon does not simply fly away. Instead, it begins what scientists call a random Walker journey, so staggered, so endlessly interrupted, that it will take hundreds of thousands, even up to 1 million years, before it ever escapes the sun's heart. This is the long sleep of photons, the prison of light. The moment a photon is released in the sun's core, it is trapped by the layers that surround it. Imagine being inside a giant, blindingly bright hall, with walls of plasma so dense you cannot see even a fraction of an inch in front of you. The core itself is unimaginably compact. Each cubic centimeter holds about 150 times the density of water, and temperatures soar to nearly 15 million degrees Celsius. Photons are created here, deep within this pressure cooker of hydrogen and helium. But as soon as they are born, they collide with the nearest particle, an electron, an ion, or another atom. And when they collide, they scatter. The photon is absorbed, re-emitted, redirected. Its original path is lost. Instead of a straight shot, the photon's existence becomes a blur of endless interruptions, like trying to leave a crowded concert hall where everyone keeps bumping into you, turning you around, and pushing you in the wrong direction. This is the essence of the radiative zone, a place where light cannot travel freely. The random walk. Scientists describe this endless wandering as a random walk. In simple terms, the photon takes one small step, collides with matter, and is forced to step in another, random direction. To imagine it, think about trying to cross a football stadium blindfolded, while thousands of people shove you from all sides. You want to reach the exit gate, but each push sends you spinning in a new direction. After hours of this, you might still be near the same spot where you started. This is the reality for photons inside the sun. Each step they take might be just a centimeter, maybe less. Then they are forced to scatter, and scatter again. Millions upon millions of times. They repeat this dance. Mathematically, the process is astonishing. Even though the distance from the sun's core to its surface is only about 700,000 kilometers, the photon's journey through endless collisions stretches that into hundreds of thousands to millions of years. From our human perspective, it's almost unthinkable. A photon born before the dawn of civilization, before the first humans walked the earth, may only now be reaching the surface of the sun, preparing to begin its final sprint to our planet. The maze of creation. Let's pause and create a picture in your mind. The radiative zone is like an enormous labyrinth, a cosmic maze with no clear exit. Walls are not made of stone, but of plasma so hot and dense it behaves like a liquid ocean of energy. Each photon enters this maze unknowingly, bouncing from one wall to another. But unlike a maze on Earth, there is no map, no strategy. The photon's path is nothing but chaos. It wanders in silence, echoing through the sun's hidden corridors, a whisper of light that will not be heard for millennia. And yet, this wandering is not meaningless. Every collision transfers energy. Each re-emission nudges the sun's layers, heating them, sustaining the great star that lights our world. The photon may be lost in time, but its presence keeps the sun alive. Asleep without dreams, why call this journey a long nap? Because from the photon's perspective, time barely exists. Photons travel at the speed of light, but they are trapped in an endless cycle of absorption and re-emission. For them, there is no awareness of years passing, no sense of delay. For us, however, it is like watching someone fall into a slumber that lasts 10,000 lifetimes. Entire species rise and fall. Ice ages come and go. Empires are born and collapse. All the while, the same photon continues its slow-motion crawl through the sun. It is as though the light of the sun is sleeping, suspended in a dream of collisions, waiting for the day it will awaken and shine upon a world that does not yet exist. The sound of wandering now imagine this process not in silence, but as an ASMR soundscape. Every collision is like a faint tap, a whisper of energy against the plasma walls. The photon drifts, pauses, scatterstep, tap, shuffle, like footsteps in an endless hallway. Millions of voices, quiet and distant, hum together in a soft cosmic choir. It's not the violent roar of fusion, but the hushed murmur of persistence, the sound of light that will not give up, no matter how many obstacles it faces. If you close your eyes, you might hear it, the soft echoes of photons wandering, their journey stretching across the eons, from trapped light to future sunrise. And then after thousands upon thousands of centuries, the photon finally approaches the boundary of the radiative zone. Here, the density of matter begins to change. The collisions become less frequent. The chaos begins to loosen its grip. The photon is still not free, but it is closer than it has ever been. Ahead lies the convective zone, where currents of plasma will carry energy outward more directly, like boiling water circulating in a pot. For the photon, this is the first hint of liberation. The long nap is ending. The endless maze is nearly behind it. What began as a spark in the sun's nuclear heart is now ready to rise, to travel the last steps toward the surface, and eventually to break free into the universe. A lesson in patience. Chapter 4. Breaking free, from surface to space, after an almost unimaginable wait. After a labyrinth of collisions and diversions lasting hundreds of thousands of years, our tiny photon has finally reached the sun's outer layers. What began deep in the heart of chaos, in the crushing heat and pressure of the sun's core, is now approaching its final moments inside this great star. This chapter is about the breaking point, the moment when the photon leaves behind the suffocating walls of plasma and emerges into freedom, racing through the cosmos toward us. The convection zone. The last obstacle, the photon's first stop, is the convection zone, a region where heat is transported, not by slow radiation, but by motion giant currents of plasma rising and sinking, much like water boiling in a pot. Imagine enormous bubbles of superheated gas, each the size of continents, swirling and churning. Here, photons no longer drift endlessly in a random walk. Instead, energy is swept along by these great convective rivers. It's turbulent, violent, but also efficient. The photon is now part of a current that is finally moving outward, toward the edge of the sun. The convection zone extends across roughly the outer 200,000 kilometers of the sun. That may sound vast, but compared to the journey already endured, this is the final stretch. The photon is being carried, almost like a passenger, to its ultimate exit. The photosphere, the sun's shining surface. And then, at last, comes the photosphere, the surface of the sun as we see it from Earth. It isn't a solid surface like the ground beneath our feet. Instead, it's a glowing shell only a few hundred kilometers thick, where the plasma becomes transparent enough for light to finally escape. This is where our photon is set free. For the first time in its entire existence, it moves unobstructed, no longer bouncing and scattering. It races outward, breaking away from the star that held it prisoner for so long. Here, the sun's light emerges as the brilliant, blinding radiance that fills our sky. It is here that the light we know, the warmth on your skin, the brightness of a sunrise is truly born in a form we can see. The great contrast, a journey of ages versus minutes. Now, pause for a moment and consider the scale of this story. Inside the sun, a photon can spend 100,000 to 1 million years trapped in its labyrinth of plasma. And yet, once free, it crosses the vast gulf of space 150 million kilometers from the sun to Earth in just about 8 minutes and 20 seconds. Think about that. A journey that was slower than the growth of mountains, slower than the shifting of continents, suddenly transforms into a sprint across the void. After ages of delay, the photon now moves at the fastest speed possible, the speed of light. This astonishing contrast is one of nature's greatest ironies. A light particle that spends eternity imprisoned, only to dash across the solar system in the blink of a human eye. A reflection. The story in every ray, and here's where the story takes a poetic turn. Every ray of sunlight that warms your face in the morning, every golden beam that glitters on the surface of the ocean, every photon that helps a tree grow, each of them carries with it the memory of that ancient struggle. When you step into the sunlight, you are touching light that has been on a journey longer than all of human history. It was born in the fiery core of the sun, imprisoned in a maze of collisions, and then finally set free to cross space and meet you. It's a reminder that the warmth and brightness we take for granted are not simple gifts. They are the result of a long, patient process, the universe's way of showing us the value of persistence, of endurance, and of time itself. The gift of light, foundation of life. Once the photon reaches Earth, its impact is extraordinary. Sunlight fuels photosynthesis in plants, forming the base of nearly every food chain. It drives the weather, shapes the climate, and powers the rhythms of life. Without it, Earth would be a frozen, lifeless rock. Human history itself has been carved by light. Ancient civilizations worshipped the sun as a god, recognizing that all life depends on its power. Even today, solar energy remains one of the most promising sources of clean power for our future. Every moment you breathe, every heartbeat you feel, every meal you eat is touched by the photon's story. Without sunlight, there is no life. Without its journey, there is no us. The poetry of a sunrise. Perhaps the best way to truly appreciate this is to think of a sunrise, when the first light spills over the horizon, painting the sky with gold and crimson. You are not just witnessing a new day, you are witnessing the arrival of ancient travelers. Photons that began their journey before humanity even existed have finally found their way to your eyes. That sunrise is a reminder of continuity, of the silent connection between us and the star that sustains us. It is both ordinary and miraculous, both daily and timeless. Closing thoughts. So the next time you stand in the sunlight, remember, you are touching a fragment of the sun's heart. You are being illuminated by energy that endured a million-year struggle before racing across space to find you. This is the story written in every ray of light, a story of patience, endurance, and freedom. And it's a story that continues to shape every living thing on Earth. Chapter 5. Echoes of the Sun and the Future of Discovery. For as long as humans have walked the Earth, we have lived beneath the sun. It has been our clock, our compass, our life-giver, and our storyteller. Every sunrise told us when to rise. Every sunset reminded us to rest. Before we could measure time with gears or digital numbers, we measured it with shadows cast by the sun. Before we understood biology, we instinctively knew that warmth and light meant survival. And yet, for all its familiarity, the sun remains one of the most profound mysteries in the universe. Every photon that reaches our eyes is more than just energy, it is a message. An echo of processes unfolding deep within the heart of a star. To study sunlight is to listen to these echoes, to search for hidden truths about the cosmos and about ourselves. The sun, as a scientific beacon, the sun is not only a source of warmth and light, it is also a natural laboratory. By studying its light, we learn about fusion, the very process that powers stars across the universe. Scientists have developed ways to listen to the sun through helioseismology, the study of waves that ripple across its surface. Just as seismologists use earthquakes to study Earth's interior, helioseismologists use these ripples to peer beneath the surface of the sun. Each vibration, each subtle oscillation, tells us about the star's inner layers, the rotation of its core, the flows of plasma, the hidden movements that shape sunspots and solar cycles. Then there are the space observatories that extend our eyes beyond what the human senses can see. NASA's Solar Dynamics Observatory, SDO, watches the sun around the clock, capturing it in ultraviolet X-ray and extreme wavelengths that reveal explosive flares and coronal loops. The Parker Solar Probe, humanity's daring emissary, has plunged closer to the sun than any spacecraft before, actually flying through the sun's corona, the outer atmosphere, to feel the plasma and magnetic storms firsthand. These tools transform sunlight from something we merely experience into something we can decode. Every particle of light carries encoded information. Its wavelength tells us temperature. Its polarization tells us about magnetic fields. Its spectrum tells us about elements forged in the sun's furnace. Each photon is not only a travelote, is a messenger. Mystery is still burning, but for all our progress, the sun continues to guard its secrets. Why, for example, is the corona, the outermost atmosphere of the sun, hotter than the layers beneath it? Logic suggests it should be cooler the farther you go from the core, and yet the corona blazes at millions of degrees. What triggers the sudden eruptions of solar flares and coronal mass ejections? Immense bursts of plasma that can race across space and rattle Earth's magnetic field, disrupting satellites and power grids. And what can photons still tell us about the sun's deep interior, where pressures are so extreme that matter exists in states we can barely imagine? Every measurement, every spectral line, every flicker of brightness is another piece of a puzzle we have not yet solved. In chasing these mysteries, we are not only studying the sun, we are studying the forces that shape stars, galaxies, and perhaps even the origins of life itself. The sun as a metaphor, but beyond the science. The sun is also a metaphor. One of humanity's oldest cultures across the world have worshipped it as a god, celebrated it in myths, and oriented their monuments toward its path. The Egyptians aligned the pyramids to its cycles. The Mayans tracked its eclipses with astonishing precision. Even today, festivals of light mark the turning of the seasons, honoring the sun's eternal return. In literature, the sun has been a symbol of hope and rebirth. Dawn marks new beginnings, while sunset often carries the quiet poetry of endings. Spiritually, sunlight is seen as a bridge between the material and the diviner touch of eternity that lands upon our skin. Science tells us the sun is a sphere of plasma governed by nuclear physics, but to live beneath its rays is to feel something more, the quiet reassurance that every morning it will rise, and with it, life will continue. The human relationship with light, we often forget that our entire existence is built upon the sun's energy. The green of leaves, the food on our plates, the oxygen we breathe, all of it begins with photosynthesis, powered by sunlight. Even fossil fuels, ancient sunlight stored in the bodies of plants and plankton, are echoes of that same stellar energy. Our technology, too, bends to the rhythms of the sun. Sundials gave way to solar calendars, which gave way to modern astronomy. Today, solar panels convert photons directly into electricity, allowing us to power our lives with the same energy that fuels the cosmos. In every era, the sun has been both a practical necessity and a cosmic inspiration. The future of discovery, what lies ahead in our quest to understand the sun. Missions like the European Space Agency's Solar Orbiter will capture images of the sun's poles for the very first time, regions critical to understanding the solar magnetic cycle. The Parker Solar Probe will continue its daring dives, skimming ever closer to the sun's blazing corona. On Earth, advances in quantum detectors and spectroscopy will allow us to read photons with greater precision than ever before, teasing out faint signatures of processes buried deep within the star. Perhaps one day, we'll not only study photons from the sun, but also capture light from countless other stars with the same intimacy, building a cosmic map of energy flows that stretches across the galaxy.